Okay, I hope you're enjoying your snow day. I'm going to try to stick kind of to the slides that I had. So last Friday, I had a meeting of RIA Charitable Investments, Inc. I'm the chairman of that. We have about 30 members. Those 30 different members are all individual charities, and they put money into our fund, and our fund says, look, you can get your money out in a week or less if you just give us 1 week's warning is all we need. So we have three kind of guiding principles. First, we have preservation of capital, so we can't lose money. We don't want to take very many risks because this is essentially a money market fund set up for these different charities. They want to have high current income, so we want to take no risk, but we want to have high current income, which really you can't do both at the same time, but that's the goal. And we want to have low volatility, which is another way of saying low risk, and we'll talk about volatility. Whether I spell it right or not, we'll talk about volatility later on. So like I said, we have right now around $76 million, and those are invested in bonds, and there are 104 different bonds. There are treasury securities and there are corporate bonds. Right now we have a 3.5% current yield. So my question to you today is, what are you worried about? If you're on this committee and we have a portfolio manager out in California, what do we tell him? What are our concerns? What are we worried about? Let me draw you one picture here to kind of demonstrate perhaps what it is that I'm worried about. And remember, I don't draw too well, so this is pretty impressive, I think, for me. We're going to have price over here on the y-axis. We're going to have yield to maturity over here on the x-axis. And we're going to have, it needs to have a little more curvature than that. It's going to look something like this. So right now, let's say that we're right here. Let's just say 8% yield to maturity means we have $1,000 par value, which means the yields are currently 8%, which is not true. This is just for example. So looking at this, I can see my concern is going to be, well, what happens if yields go up? If yields go up, make that look a little bit better here. If yields go up to say 9%, then what's happened to the price of the bond? The price of the bond, I don't know exactly what it is, but this is lower than 1,000, right? It's gone down. So we know that if yield to maturity goes up, that implies that bond prices go down. So it's great to know that rule, but I want to put a little bit more on that rule. I want to have some actual numbers that I can think about with that. And in order to do that, there's something called duration. And you should have watched the duration video that gives you a little bit more background on this. But duration is going to equal to T times WT, where WT is equal to the cash flow at time T divided by 1 plus Y to the T all over the bond price. Okay, so here's how we do this calculation, and it's what you've seen before, but I want to say let's assume everything is annual pay, just to make this a little bit easier to deal with. And we're going to have 8% coupon bond, and we're going to say that it's a 10% yield to maturity. I posted on D2L a spreadsheet that will do this calculation for you. I just want to show you a couple things here to think about what duration is. And duration is a measure of interest rate sensitivity. So I'm worried about interest rates going up. I have this big bond portfolio. I know it's going to move bond prices down, but I don't know how much. So basically I know I have this 3.5% current yield, that's income coming in, but if I need to sell those bonds, interest rates go up, bond prices go down, I lose money. So I want to have some sense of the risk I'm taking here. So let's look at the following setup. We have time. Let's say it's a 4-year bond. By the way, I did the spreadsheet with 4 years. It's easier just to pick 4 and leave it like that, but you can do more years relatively easily. So you have 4 years annual pay, 1, 2, 3, 4. We're going to have the cash flow. It's 8% coupon bond, 80, 80, 80, 1080. We need to find the present value of those cash flows. So it's going to be 80 divided by 1.10 to the first, 80 divided by 1.10 squared, 80 divided by 1.10 cubed, 1080 divided by 1.10 to the fourth. Now notice how this looks exactly what we did in bond pricing before, right? If you put into your calculator n is equal to 4, payment is equal to 80, future value is equal to 1000, and interest rate is equal to 10%, then you're going to get the price of the bond. It's not always 1,000. It's not 1,000 in this case. It's going to be the price of the bond. Then we want to find the weights. So the weight, the WT, and let me do it this way because I don't want to get bogged down with all the numbers here. Let's call this A. Let's call this B. Let's call this C. Call it D. Whatever that number turns out to be. So the weight here is going to be A over P for the price, B over P for the price, C over P for the price, D over P for the price. I sum these up, they're going to sum up to be 1. I know that because this is just the weighted average, is a way to think about it, weighted average of the cash flows. Then I do W times T, so it's going to be 1 times A divided by P, 2 times B divided by P, 3 times C divided by P, 4 times D divided by P. Sum that up, and that gives me my duration. Okay, so a couple things to think about, and these are listed in your textbook. What's the duration of a 0 coupon bond? So if I have a 0 coupon bond, what's its duration? Well, then this would be 0, this would be 0, this would be 0, and your cash flow here would be 1,000, right? So I know that this is 0, this is 0, this is 0, this is 1, because all my money comes at the end, and 1 times 4, my duration would be equal to 4. So I know that the duration of a 0 coupon bond is equal to its maturity. So I know that for sure. The duration of the 0 is equal to its maturity. What's the next thing we want to think about? Let me get rid of this real quick. If coupon rates are higher, what does that mean? The higher coupon rate implies a longer duration. Why is that? It's kind of the exact opposite argument over the 0. The bigger these numbers are, the greater the weight in the out years here. The next, the time to maturity, the greater the time to maturity, the greater duration, because all else being equal, of course, because duration is a measure of the weighted average life of the bond. The longer the maturity of the bond, the more likely is you have a longer duration. If the yield to maturity is lower, the duration is higher. So those things you can look up in your textbook. Those are just kind of things to memorize, those facts. The coupon rate is higher, duration is longer. If time to maturity is higher, duration is longer. If yield to maturity is lower, duration is higher. The duration of a 0 is equal to its maturity. And the last one is the duration of a perpetuity is equal to y 1 plus y over y. So that's the duration of a perpetuity. So let me leave you with a couple more things that I know. I know that the duration of a portfolio of bonds is equal to the sum I equals 1 to n of the weight of the bond times the individual duration. In other words, I have this portfolio of 104 bonds. So I have bond 1, I have a total of $76 million, right? The value of bond 1, let's say, is $1 million. So the weight of 1 is equal to 1 million over 76. The weight of bond 2 is worth $5 million. It's the value. The price is $5 million, so its weight is 5 million over 76. So I take the weight of each bond, multiplied by the duration of that bond, and just sum it up. I do that for all 104 bonds, and that tells me the total duration of my portfolio, which in our case is 2.5, and people will call this 2.5 years. So the other fact I want to leave you with is the change in the price. Actually, do it in blue here. The change in the price of my bond, or my bond portfolio, the change in the value, is equal to minus d star. D star is modified duration times delta y times the original price of the bonds. Now d star is equal to, the modified duration is equal to what's referred to as duration, or Macaulay duration, divided by 1 plus y. Okay, so if we think that the yields right now, let's put in the terms of the bonds we have right now, in this portfolio with the RIA, charitable investments, we'll say that the duration is minus 2.5 years. I gotta get that modified duration, divided by 1 plus the yield to maturity. Let's just say the yield to maturity is 3.4%, so 1.034. So my current yield to maturity is 3.4%. That's different than my current yield. And then I'm worried about yield to maturity going up. Yield to maturity now is 3.4. I'm worried that's going to go up to 4.4. So it's going to go up 100 basis points. So make sure you have that terminology. It's going to go up 100 basis points. So that's up 0.01 times the current value of my bonds, $76 million. So this tells me, I'm not going to do the math here, this tells me the change in price I can expect for my $76 million bond portfolio if rates rise 100 basis points. The 2.5 is the duration. So here's what I have to think about. All right, I think interest rates are going to go up. I can adjust this duration number. I can buy longer maturity bonds or shorter maturity bonds, higher coupon, lower coupon. I can adjust those 104 bonds in my portfolio to make this number larger or smaller. If I think interest rates are going up, what will I do? Well, if I want to make a bet on market timing and think that rates are about to go up, I want to make duration, that's an ugly D, I want to make duration go down. If I think that rates are going to go down, I will make duration go up. So right now in our last meeting, we're like, all right guys, I think the Fed's going to taper. I think rates are going up. Let's move this duration from 2.5 down to 2, or maybe we'll move it down to 1.5. If you do that, you're giving up current income because you're getting shorter maturity bonds that have a lower yield. So you're giving up money right now with a bet that rates are going to go up, and you'll be able to reinvest later. But that's what duration does. Let me leave you with just one thing to do here. I want you to do the following 4 things. I want you to find the duration of a 4-year annual pay bond, 8% coupon rate, and there's a 10% yield to maturity. And number 2, I want you to find same thing but a 2% coupon. Find the duration of a 2% coupon, 4-year annual pay with 10% yield to maturity. And number 3, I want to say, look, call this, by the way, call this bond A, and call this bond B. And I want to say you have a portfolio that's 75% A and 25% B. I want to know the duration of that portfolio. Number 4, if the yield to maturity drops to 9.5%, I want to know the change in price of bond A, the change in price of bond B, and the change in price of the portfolio. Alright, pause right there. I'm about to put the answers up for all but one. So the answers for all but one, the duration, make sure you've worked this before you cheat here. The duration of this one is 3.5617. Bond B, the duration is 3.8625. The duration of the portfolio is 3.6367. The change in price of bond A is 15.16, and that's positive because it was a drop. And bond B has a change in price of 13.10. And I'm going to leave this for class discussion to get for that portfolio. Okay, so I'll post a couple more videos later on. I'm about to go play in the snow with my little girl. I hope you have some fun in the snow, and get more videos up later tonight.